Hi guys, welcome to Let's Get to the Marks. And what we're looking at today is E-Z Isomerism. So let's get into it. The first thing we need to know about E-Z Isomerism is that this type of isomerism can only happen when there is no rotation around the double bond. What do we mean by that? Well, let's take a look at my molymod. I have but2ene. So I have a methyl group here. I have the carbon-carbon double bond here and another methyl group below the double bond. I want to try and get this methyl group to appear up here next to this one. Now I can't. Due to the nature of a double bond, there is no rotation. I try and twist it, but I can't rotate that up there. Now, if I make a slight adjustment, and I remove it and make this a single bond where the carbon-carbon double bond is, look what I can do now. I can rotate, so I have my two methyl groups on the but2ene up here. So when there is a single bond in between, we get free rotation around that central bond. As soon as I go and place a double bond in there, like so, I get no rotation. So for E-Z isomerism, no rotation around the double bond. Little spelling mistake. Also, for E-Z isomerism to occur, it's only going to happen if there's two different groups attached to the carbon atoms on the double bond. So here you can see this carbon atom has a chlorine atom, a hydrogen atom, and this carbon on the double bond has a fluorine and a methyl group. If we can't, so will E-Z isomerism occur in that one? Yes, it definitely will. However, let's have a look at this second molecule here. We can see that we have a chlorine attached to this carbon and a methyl attached to this carbon. That's two different groups. But when I come to this carbon atom, it has two identical groups attached to it. Now, when that occurs, two identical groups attached to one of the carbon atoms, this molecule is not going to show E-Z isomerism, okay? So now that we've established how we achieve E-Z isomerism, let's look at how we name the different isomers. Do we call them an E isomer or a Z isomer? Let's get into it. Okay. There are two types of isomer we can get, just messing around with my camera there, guys. There are two types of isomer we can get from E-Z isomerism. Z isomers have both of the same groups, either above or below the double bond. So let's look at one. Here we have Z but2ene. So let's look at that. I want my double bond. I'm going to have a methyl group above and another methyl group above, and then below a hydrogen atom and another hydrogen atom. When I do this, because there's no rotation, those methyl groups are trapped above and those two hydrogen atoms are trapped below the carbon double bond. We say this is a Z isomer when two of the same groups are above or below the double bond. We call this a Z isomer. Now, apparently, Z means zusammen, which means together in German. Let's look at another Z isomer. Let's look at Z2,3-dichlorobutene. So, same kind of thing. We want a double bond. This time, we're going to attach two chlorine atoms above. Oh, we'll just do the hydrogen below. I could have done the hydrogen below or chlorine above. It doesn't really matter. We have the same thing. Two groups above that are identical, and there's two below that are identical. Now let's move on to the E isomers. Now, apparently, E means antigen, and that means opposite or different. So let's have a look at E-butene. Let's put one methyl there, and then opposite, we're going to put the other methyl. I'm not very impressed with my threes there. Okay, so if we look here, these guys are opposite each other, and they're trapped like that, opposite each other. So we used to call these trans, but they've and people still do use trans and cis. Trans meant across, cis meant together with the Z isomers, and E isomers were called trans. But people have switched to E-Z Isomerism because there is a way that it helps us, which the cis and trans method doesn't. But really now you just need to know E-Z isomerism for most chemistry A-level specifications. So let's look at E2,3-dichlorobutene. So we're looking at, again, we have to have a double bond. And this time we're putting the identical groups opposite each other. So you can see these are opposite each other, across from each other. And that's what antigen means, opposite. Right, let's get into the slightly more difficult stuff to do with E-Z isomerism. E-Z system still works even when there are 4 different groups around the double bond. We can still classify the molecule as either Z or E. So let's draw one and show you how to do that. It would help if I have my pen on. Pen on. Okay, so this molecule here has 4 different groups, and we can still classify it as Zusammen, 2 groups on the same side, or antigen, groups across from each other. Well, how do we do that? We use something called the SIP priority rules. Now, this stands for the Carning-Gold prelog, the SIP bit, and they're just really the 2 scientists that came up with these rules. And what we do is we look at the atomic number of each atom or species or group that is attached to the carbon double bond. So I'm going to number my carbons to make it easier to talk about. I'm going to call this carbon 1 and this carbon 2. So let's look at carbon 1 first of all. And if we look at bromine, we can look up its atomic number in the periodic table and find that bromine has an atomic number of 35. And then we can look up chlorine in the periodic table and find that chlorine has an atomic number of 17. So the bigger number, which is bromine, has a higher atomic number. We're going to label this as a high priority group. And we're going to label the chlorine as a low priority because its atomic number is less than the other group on the same carbon atom. Let's go to carbon number 2. If we look at hydrogen, it has an atomic number of 1. And if we look at fluorine, fluorine has an atomic number of 9. So we're going to label the high priority one and the low priority one. And this time, fluorine is high priority as its atomic number is bigger than hydrogen's, who we give low priority. So the 2 high priority groups are opposite each side of the double bond. One is above, one is below, and they're across from each other. So this is known as an E-isomer. Right, let's look at a slightly more complicated version. Another solution. So let's stick with chlorine and bromine there. Let's put a methyl group here. And let's put an ethyl group here. Okay, I could write these without displaying all the bonds, but why make life easy for myself? I'm going to number the carbons again so that to make it easy to talk about. So And you might think, why am I bothering with this numbering of the carbon atoms on the double bond? But there has been a 6-mark question before, even in the AQA chemistry A level, where they didn't just ask you, is this an E or is this a Z isomer? In the 6-mark question, they said, explain how you know which one it is. And you had to talk through this process that I'm going through now, the SIP priority rules. So you had to say, I go to carbon 1 first. I look at the atomic number of the bromine and the chlorine. And I say, well, the bromine has a higher atomic number than the chlorine, so the bromine is high priority. And the chlorine with the lower atomic number is low priority. We then look to the second carbon atom of the double bond, and we look up above it and we find we have a methyl group. Now the atomic number is 12 of the carbon atom directly attached to the double bond. Aha, we have a problem. The atomic number is also 12 of the carbon atom directly below the double bond. They've got the same priority. How do we sort out which one is the higher priority and which one is the lower priority? Well, how we do this is we go to the next atom attached. And the next atom attached to the carbon is, well, another carbon. And so, or the methyl group. Whereas here, the next atom attached is a hydrogen atom. So we decide that this is lower priority as the atomic number of the next atom attached, or the next different atom attached, is lower than here with this one. So this becomes higher priority. So once again, the reason why we did that is they both had a carbon with an atomic number of 12 attached. So we then look for the next different atom that's not the same. And we find that this one has a carbon with a 12. And the most we can get out of this one is a hydrogen with a lower atomic number of 1. So what do we end up with in this situation? Have you worked out whether it's Z or E isomer yet? And as both the lower priority groups are above the double bond and both the higher priority groups are below, we call this one a Z isomer. Okay, guys, that was E-Z Isomerism. I hope it helps. Check out some of the other videos on the channel and let's get to the marks.